So it can be quite difficult to follow it in words, and so this flowchart will help you understand what happens. So here I am, I'm starting, and I want to send a data frame. I listen. Did I previously set my nav? If I do, then I go back here and I wait until that nav expires down to 0. If it's expired down to 0, or it is already 0, then what I'll do is I'll go on and physically sense the medium. And so I'm listening. Do I hear any noise, any signals in the band? As long as the noise is below a threshold, I will assume, oh, it's okay for me to transmit. If there's noise there, then I will assume that the medium is busy and I cannot transmit. I will come here, wait a random period of time, and try again. If the medium is idle for a random period of time, then I will go ahead and transmit my data frame. If I don't get an acknowledgement back, I will assume a collision, and then I will recalculate my random backoff period, and then I will try again. And I keep following this process until I'm finally able to transmit. And each time I come down here and I have a collision, I double my contention window from how I calculate the random backoff period. And in this way, as my random backoff period is selected from a larger and larger number, I'm avoiding collisions with other wireless LAN devices that are operating, and eventually I'll get an acknowledgement back. Now, the heavier the wireless LAN is loaded, then the more collisions I'm going to get, and therefore the performance of the wireless LAN will go down. So most access points will limit the number of clients that are allowed to connect, simply because if it allows too many clients to connect and your collision rate goes up, your performance will go down considerably. So here is an illustration, and in this illustration I have an access point and I have two stations. Station 1 wants to transmit. At point 0 it says, oh, my nav is 0 and the medium is free. So I then wait what's referred to as a diff, a DCF interframe spacing interval, plus my backoff period, calculated using a random number selection. If the medium is free all during this time, I will go ahead and send my MAC frame. In the MAC header, I will include the duration value, which includes the time it will take me to send my frame, plus what's referred to as the CIF, plus the time the acknowledgement takes to come back. Station 2 can hear Station 1. When it hears this data frame, it will set its nav. And Station 2 will not transmit during this time whether or not the medium is free, because it knows that it's been reserved using the nav. Now the CIF is the short interframe spacing interval, and this is defined in the standards as the time it takes for the receiving station to process the incoming frame and to send a response. So the acknowledgement must be sent within a CIF. And remember, when the acknowledgement comes back for this data frame, the duration value in the acknowledgement is 0, and anybody hearing that acknowledgement will then set their nav back to 0, in which case they can start their transmission period of listening is the medium free, waiting a diff plus a random backoff period, and then trying to transmit.